Hello, good morning. You get kudos for finding this room. Anyone have trouble with it? Me too. So this session we're going to be talking about visualization best practices for explainable AI. This is something that the entire industry really will be going through, I would imagine, for the next few years easily, because right now the language a data scientist speaks is a totally different language than the rest of the world. Can I get a sense of hands for the data scientists in here, like a PhD? Okay, none of you are allowed to ask me a single question. You're grounded. Put your earmuffs on. No, seriously, I have 2 years of data science myself. I am not a full-on PhD. You can easily trip me up. I do work with over 200, and we can get you the answers to things. I'll tell you, though, it is so deep in certain ways, so I'm going to scratch over the surface on a lot of different areas, but also touch on some fantastic resources that I found in this space to continue to dive deeper in this. So just the agenda this morning is a quick introduction into this concept, storytelling for machine learning projects. I'm going to walk through several examples. Was anyone in my session yesterday? Okay, I'm going to be showing the healthcare one first and go much deeper into it, and then be showing another one. So if you see that, you don't necessarily have to run out the door. I'm going to go much deeper this time around. Then we're going to walk through some recommended next steps and other resources, and I'm going to inspire you with things that I'm seeing my data scientists send to me, as well as things that I'm just seeing as I bridge the world here. For folks that don't know me, I'm a former Tableau Zen master from the old days, 2013, 2014 timeframe. I also redesigned a competing product, so don't be angry with me, for Microsoft. In the market, and then advised probably over 100 analytics vendors on different small engagements while I was waiting out my non-competes, and joined DataRobot last year. They were one of the clients I'm advising. So I've been around 23 years, been playing with this a long time. One thing that I'll say is similar, it doesn't matter whatever I've done through the years, the technology continues to simplify, but the people now are the most complex piece of the process. And especially in AI projects, one of our stakeholders for AI Experience London, an insurance company, mind you, the executive stakeholder for the project says, well, I want to meet AI. You're doing a really good job. Ugh, AI is not a person. So then there's a huge gap in even understanding what on earth that AI is. And I joke, we have this marketing slide at DataRobot. Just had data hit start. Yes and no. There's a bit more to this in the process. It's very simple to get started to experiment with your data very quickly and find patterns, and I'll be walking through a use case on this in just a moment. Now the machine will automatically develop and evaluate and look at hundreds of models, where when I was learning this myself in school and applying this in business in 2003 all the way until I found DataRobot, I was developing one model at a time and scripting or dragging and dropping, and it took forever. So now this really is radicalizing and disrupting. I'd say there's twice in my entire 23-year career I've seen tools and solutions where I've said, wow, this is going to change the game. And it was Tableau at the time when I saw that in 2009 and said, wow, this is going to change the game. You don't have to write queries anymore to develop visualizations and to hook up parameters and dashboards. It's much simpler. Now, when I look at DataRobot, I see that similar and other automated machine learning tools in the industry. You don't have to code Python and R and drag and drop crazy one at a time things anymore. It's really simplified, and this AutoML movement will really change things. But what really is the huge gap today, and it's going to be exciting to see explain data in Tableau, and how that takes us, because historically Tableau's been a wonderful leader in bridging data to the business and driving the data-driven culture, and now we're elevating to an AI-driven culture. But this is my life every single day with 200 data scientists. Oh, this looks amazing. What does this mean? Oh, you know, the log loss of this, and the rock chart, and the AUC, and the F1 score. Oh, none of this means anything to me. I need to have this translated to a business outcome and understand, does this mean we're going to be less profitable? Does this mean we're going to lose a customer? What is the financial impact of that? Your executive that doesn't know who AI is and doesn't realize that's a technology, they think in numbers, and they think about what they're measured on. So the keys to AI success, and you start using machine learning and using advanced analytics, this whole concept of AI interpreter, this is a role that I'm seeing in very successful implementers and early adopters of automated machine learning, of just translating what the output means to the business. And guess who's in the best place to become an AI translator? It's this group right here. You know the data, you know the business, and you know the nuances of the executives and leaders that you're building reports or dashboards for today, what makes them tick. And it's that magic that will really help skyrocket the impact that you can have with predictive analytics. The other key is transparency. So today we're going to open up the black box of models, and for the first time in my life, I really started to understand this past year, working with all these data scientists, all these in-between steps of the process and what influences the predictions. And that is fascinating. And there's so much insight that you can get just by opening up that black box. And essentially by doing that and understanding why did the machine make a decision, you can gain trust in that technology. So when you think about this, and as we walk through some of the examples today, we'll be talking about what do those models' results mean, and that's again translating or interpreting that for the business. How does the model work, and building storyboards around what's your proof points for the outcomes. And then of course, asking it questions and getting answers that make sense. So as analytics and more of this becomes automated, the human is still absolutely critical, from everything from choosing the right data sources, knowing the business process and all the external conditions that can affect an outcome, to making sure that there's no bias, correcting mistakes for the machine and continually improving this, and even being ethical. The machines don't know anything about ethics, and that feeling that you just say, this isn't quite right. So storyboards. When you think about machine learning, and as I go through the different results today, it's really the same pattern, and it doesn't matter really what solution or tool that you're using. I'm from DataRobot, yes, but this can apply to R and Python and many other solutions as well. You'll define an AI use case, and you'll set projects and goals. Then when you start to dig in and open up this black box, you'll build models, and you get stakeholders to identify with this. You'll find what actually influences outcomes, the relationships between those features, and they can really be quite interesting themselves, the prediction explanations and reasons. And then you'll look at model performance, and you'll assign some prices to this. And when I say prices, maybe some values to how much is a lost customer. So if you think about customer acquisition cost, and you also have to think about some of those soft costs, so things like customer experience, if you have a bad result, and analyzing and looking at those payoffs. So let's walk through a quick example. I'm going to show, first one is going to be healthcare. Hopefully this is a topic that everyone can relate to very easily. And this is a dashboard designed by Bridget, who is another fellow Zeb Master, but I think a current one, Josh Milligan and Will Gray. We're also going to review the what if extension. This allows you to ask some questions. It's available in the Tableau gallery. And again, you can experiment a bit. And a lot of times when you're developing, even just before you really develop a model, you may just experiment with the data. So I'm going to go through a little scenario here, and being the great little storyteller that I am, we're going to actually use a use case for this. So here I am, I work for a hospital, and I'm in the finance department, and I get a call, ring, ring, hello, yes, oh, readmissions, oh, audit, fines, oh, this is not good. Yes, I'll absolutely look into that right away. So as a financial analyst for hospitals in healthcare, it's not a good thing if you take care of a patient and the patient keeps coming back. You didn't help me, I'm still sick. So this is that scenario that we're going to be looking at. And in the dashboard, actually, let's do this first. Let's look at the data set. So as an analyst, we'll put zoom it on here. I'm going to be looking at my patients and the data. And what you'll notice is it's not perfect. Our data's not clean and whatnot. It's kind of messy. It's all over the place. I have lots of different values in here. And for each value, I'll have a different one at a time outcome. I also have some free text as well in here. So what I can do to build a model is simply go to DataRobot. I can connect to many different things, but I'm going to go ahead for this particular one and just bring in my data here for my readmissions. And what it's going to do and what it's going to automate is that exploratory analysis that I would have manually done before. What is the summary statistics? What is the distribution of the variable? Is it skewed? Is it not skewed? Do I need to look at things like outliers that can affect models? It will just kind of take a look at things like correlations of the features themselves. So as I explore in here, and the machine's done this for me, I can pick any one of these variables and kind of take a peek at this to get a feeling for, oh, we have a lot of older patients in this particular case, not lots of younger ones. But I can just get a different feeling for all the different datas. From a prediction standpoint, I'm interested in readmissions. I can go ahead and say that for the data scientists that are in here, I'm not going to be digging into this, but there's lots of geeky things in here that you can continue to sample and customize all sorts of things we have here. But the machine has identified readmission as a classification. That's what we're going to do. We're going to classify who's been readmitted or not into the hospital, and then find out why. So to do that, I click this big easy start button. And the machine now is going to do what we do in machine learning with. It's going to take different sets of data. It's going to hide it from the answer. So it'll run it through. We call these partitions and holdouts. So that we don't want to give it all the answers and train it with all the answers. We want to make sure that we test it with some data it hasn't seen before to make sure it can answer correctly. So what it's going to do now is it's going to run through a bunch of models at a time, and this doesn't take very long. I now have set this up to 20, so I can run 20 models at a time. And mind you, this used to be one at a time and used to take me a long time to do. We have Python, we have R, Valpal Rabbit, there's some of these little robots, TensorFlow. There's many different types of models that it's going to run here. And I'm just going to let it keep running and playing. And like a good cooking show, I'm going to show you the end result. We're just going to jump around a little bit. So one thing I'm going to do is I'm going to look at maybe some of the feature associations. And right away, we can get some insights here with clusters and with just looking at what matters the most. And being the old lady that I am, I have to put my glasses on. I've decided no more demos without being able to see anymore. But in here, we can take a look at things and you can see a little bit of some of the patterns in here for the data. And this is information if you've done correlations before, just taking a look at what are the strongest types of associations that I can have. For folks that are familiar with the concept of Kramer's V, you can see it pop out a little nicer now. But you can get a feeling for this. And to look at this and I say, well, now I want to translate this to the business somehow in Tableau. A lot of the different visualizations in DataRobot can simply export. We have APIs as well. So I've taken the same information here and I've decided here, I just want to let the business know what actually might influence. And here I've got, it's the changes in insulin it's the highest one. So the range here, and I've done a few things, I've put this, instead of saying a feature association matrix, I've said this is the strongest associations to patient readmissions. So I'm associating this to the outcome that would be reviewed, and also letting them know what the range is. So from a 0 to 1, I don't expect my audience to know what a Kramer's V is. And some other ones, I have some other tips on this. But one thing we're seeing is changes in insulin. And ironically, my dad has diabetes, and he changed his insulin, really. And I just ran this data to do this demo for this conference and said, oh, wow, now I'm a little more nervous about him, because he said he wasn't feeling well when I left. So it is interesting. But you can see here the things that make a difference. Now, it's not immensely informative, but at least right away, out of all of those variables on that spreadsheet that I had, I know now these are the ones that are really influence the outcome a bit. But I can continue to dig in. And as I go back to DataRobot and I dig into these models, when I say, yeah, this doesn't mean a whole lot to the business, I now have 80 models. And if I were to go to the business and say, oh, yes, here's the log loss, and it's 0.6067 or whatever these things are, again, that doesn't mean a lick of anything, and it's not very useful. But as you dig into the models, and by the way, this is all the data prep work that's been automated for you. So from that perspective, if that was miserable before, that's gotten a lot nicer now. I can dig into understanding. And I like this visualization. I'm seeing it in multiple tools in the industry, not just ours. This allows you to see now what matters most as you influence those outcomes. And in this case, the discharge distribution, the number of inpatient stays, so how often that person comes back, how sick they are is one thing. The medical specialty themselves, but we still wonder, what is it, right? Number of diagnoses in labs. This information alone, if you think about it, you can assign resources to what matters most. And if you're assigning resources to things that just don't matter, so gender isn't very important here, so finally we have a little bit more of gender equality. There's different things that will matter. And again, taking that into DataRobot, I can simply use this little export, or there's other ways that I can do this. I can take this as an image. For the most part, I usually use the text as well. And for folks that like APIs and integrating into the pipeline, you can do that as well. And bringing this into Tableau, I have feature impact. Now, a few tips here. I've not used the word feature in here. I've just let them know impact inpatient readmissions. Again, I've put the score between 1 and 0 so they know the range. And if they want to go and look at what this really means, you can read all about it. So those are some of the tips on that particular one. Digging down a little further into this one. We can go into feature effects. Now this one at the last Tableau conference in where was that? There was the USA conference. I don't remember where it was located anymore. They're all blending. New Orleans. It was a banking financial analyst tell me they found 200 million in money laundering activity within this visualization. It was very powerful. So when you think about AI interpreter, it was a business analyst, data analyst type person that came and found me at the Tableau conference. The bank, one of the largest banks in the world, clearly had data scientists before DataRobot and before that person was trying to play around with data science as a citizen data scientist. So it was very powerful. And it was the first time that I really opened my mind to what this particular visualization can do. And what it does, so if you want to think about this one, in data scientist terms, it's a partial dependence plot. In human terms, what this really means is if all the other variables were held equal, and we're really just looking at number of inpatient stays at the hospital, we can see this influence of the outcome here, the patterns of what more influences someone being readmitted. So you can get a feeling for right away, it's not just now this particular variable, it's the range of values. And that is very powerful information. Another example of healthcare that's real from DataRobot is Symphony Healthcare. They're finding sepsis And the ranges of sepsis, for folks that don't know what that is, it's very deadly. You know, helping them find that is important. So you can look at some of these different things and look at, you know, we were looking at emission source or the number of lab procedures. You can start to see the patterns very quickly there. And the next one I'll show is prediction explanations. So this one will give you an insight into, again, the top reasons why someone might be readmitted and may not. In expired means you've passed away. You would probably take this data out without all these in it, but in the data set that on the fly I got that phone call that I'm experimenting with, those were in there. So clearly you can see as a human and validate, yeah, that makes sense. They probably won't be readmitted. But there's other things that you can see as who might be readmitted. And you can get a feeling for it. Emergency rooms, low weights, 25 medications. That means you're probably pretty sick. And you say, well, this makes sense. And how you can use this in DataRobot? There's a few different ways that we do this. I can compute and download this. I can put this in a quick store procedure, which most folks will do. They'll put this in a database and store it so you can use all of your, if you think about all of the different permissions and role-based security and all this work that you've done to get Tableau embraced in your organization with the right level of governance and best practices, this is usually what I see folks doing with these explanations, is putting them into a table for folks that can't see what this looks like. Then in Tableau, you have the prediction itself, you'll have the reasons, and you can make this more explainable just with simple calculations. And translating this into Tableau, I can now create something a bit more exciting. So in this case now, I've actually got a story in Tableau that I've guided, and this is what Bridget and team has built. And she's gone through with the storyboarding and says, well, I want to reduce readmissions. The length of stay, is this a factor? No, not really. So she's guiding them through the story when reviewing, looking at the model itself. If this is how the model scores, and letting them know medical specialty is really one of the key drivers in this particular one. And looking at, again, some of the factors, you know, to look at. And as you look at factors, and I love this design, I think it's fantastic, is looking at not just the reasons why, and again, this is all in human language, why is Edna going to potentially be readmitted? The number of inpatient visits was 9. Outpatient visits, her diagnosis, the medical specialty, and whatnot. But we also have proactive. What are you going to do with this information? So you're always thinking about what action would someone take and taking it to the next level. So prescribing, this is, call her for her next appointment. This is the next thing to do. So it's a wonderful example of what you can do. One last thing on this particular one, and then we'll go on to some other ones, will be what-if analysis. And what I'll actually do is I'll start. I keep getting people asking me about this. So in this case, we have an extension, and we can drag an extension in to DataRobot, and I can go to the extension gallery, and where this is located, I'm looking at this extension right here. And you get a TRX file. Does everyone know what an extension is in Tableau? Good. So what you can do, and I'm going to go ahead and just search for my TRX file and find this one. And bring it on in. And so one of the ways that we can connect and work together with Tableau is simply with this extension. And again, from a governance standpoint as well, from a governance and security, we're going to be using models that have been already deployed. The data scientists have already blessed this and said this is a good model to use. And we can now easily tell the business that has no business even being citizen data scientists, we can say, let's go ahead and look at this. So we can look at healthcare patient admissions. We'll see what matters most. So we'll get those important features. And then we can start asking questions. So we can take a look at maybe the number. I'm just going to make this pretty simple. This is probably not exactly what you would do, but I want to move on to some of the next things. So we can get some idea here, predictions. We can add this to a comparison to ask a what if. So let's make these diagnoses 2. He's only been an inpatient 3 times. Instead of heart failure, we'll say kidney. And no. So just to give you an idea for how the business might ask questions that you don't want ever touching predictive models other than just consuming and using them, this is another really easy way in Tableau that you can do that. So very, very easy, right? Where do we get started? Let's see if I can remember where this is. There we go. All right, so one of the keys to machine learning and AI I've been doing this for a long time, designed a product back in Excel way back in the day at Microsoft, predictive analytics, and infusing that into the add-ins in Excel. It was ahead of its time. But one of the most common things all time when I show someone these things, oh, let's do it. Optimize profit of my business. Let's win the lottery. All these things that make absolutely no sense, that they're not an AI use case. I mean, it seems like it should be completely, if I could be living in St. John's on an island and not working, I would have predicted the lottery in Florida a long time ago. But essentially knowing what is a use case and explaining, putting some number to this and selling the vision, this is half of the battle, if not the biggest part of the battle, because the tools are so easy. So let's walk through another example of what an AI use case would be. And there is a reason why I'm wearing my lemon shirt today, because as a good storyteller, you have a theme. I've even brought my lemon purse, because, I'm just that kind of gal. Lemons. Do people know what lemons is in the context of cars? It's a crummy car. And this actually happened to me. I bought a car. I know a lot about data. In about 2010 timeframe, my car died. And I bought one at Mazda. Hopefully no one from Mazda is here. Anyone from Mazda? You might want to walk out. So this is my car. I bought it. It was. I paid in cash. I was thrilled. I thought I got a good deal. In less than 40,000 miles, the motor, it's a rotary engine, blew up. I knew nothing about rotary engines or all these different specs on cars. So you can see the dust on my car. I got HOA letters. Those are associations that I'm going to get fines from where I live. My neighbors know about this. So you think about all these costs that are soft costs for your business. So now my whole neighborhood knows Mazda is not such a good car. And it probably is not all Mazdas by any means, but they've got a bad rap now. The customer experience, Jen Underwood will never buy a Mazda again. I got a BMW the second time around. But all these different things that happen besides the hard costs, is you have a lot of soft costs that you need to think about. So what is AI? And a lot of this, we've been doing this for as long as I've been in, call this the digital transformation. Okay, it's been the digital transformation for 23 years. We just called it something else. I think we called it business process reengineering. But in this case, where and how does a model fit in? And selling it to the business, to a group that doesn't know, and they're like, oh, you just want to play with new toys. No, this is really powerful technology because it can transform your business process. And by showing them where, and I've got my little lemon there, all these steps would be avoided if we do a better job predicting my lemon car. It's that kind of thing that will influence your stakeholders, and then, oh my gosh, I understand why AI is important now, because it will improve something that I genuinely care about as an executive of a business. So some of the keys as you're designing are going to be specifying the problem itself, and it's qualitative, asking how, when, and where your model will be put to work. So having been the good consultant that I was, going to see the process of how cars are inspected was really important. And it wasn't just a car. I bought a used car. So used cars get sold in auctions, and auctions have several inspectors. They come in the morning in long lines of cars. They'll have Fords, they'll have Volvos, they'll have BMWs. They have all sorts of cars, not just the Mazda. So for a poor human, you think about when do I use AI in machine learning? Way too many variables for these different car types. Each car type had a different inspection type. Oh my goodness. But what we did have, and I'll get to this in a moment, of how do I make this accessible to them, is we have the data. So we have VIN numbers for cars, and we have the data on recalls and problem cars. We can put this in a mobile app while they're scanning and looking at the car and inspecting it. And that's what we're choosing to do. Then now we're going to look and say, how many bad cars do we have now? How many good cars do we think we can get? And we're going to set a baseline, because now you can be a superhero and ask for a raise if you've improved the money of the business, the profitability. And how are you going to measure that success? It's not going to be instant. It's going to be over time, and you're going to keep improving and learning more and saying, oh, now we know about this data, and we'll add to it. So what does this look like? So at DataRobot, we work with thousands of customers, and the types of format that we usually will use is describing what we call the use case. In this case, we want to reduce lemons. We're putting a value to it. In this case, okay, total about 50 billion cars go through. 4.2 million of the inspections happen with those poor people running around the car. 252,000 are sitting there with dust in a driveway like Jen Underwood's car. Really crummy. So you put some value to this, and we say, wow, if I can deliver this 105, let's pretend this says euros. I know where I am. But then we look at some other things. We look at the value itself. It's a high value. Yeah, this is something we should pursue. How hard is it? Not actually, in this case, it's not going to be too hard. So as you develop models, you may have more than one model. So you may look at things like customer lifetime value and predicted ability to churn or leave your business. You want two predictions. So sometimes it may be a little bit more difficult. But then you'll look in and say, well, how much is this going to cost us? In this case, it's easy, so it's not too bad. We're going to put it in a mobile app and scan it. It's very doable. So the next key, and this is my secret to success for as long as I've done consulting, applications, product management, you name it, is mocking it up. And it can be ugly. You don't have to be the best. This is my hack job in Photoshop, in PowerPoint. So essentially, my idea is to have the inspector scan the car. We're going to say whether it's a predicted good or bad one, and just make it really quick. And then all those data points that they really wouldn't know, there's just too much to look at. We're going to make it really simple. We're going to highlight and say where to look. So not only does the business get this, oh, yes, let's do that. So when you talk about an idea, but then you show an idea, it's so much more powerful, and that's AI. The other key that I have found, and I have so many stories of showing DataRobot and having executives be completely glossed over and, oh, they don't know what to do with this. But, and for as long as I've been in the industry of consulting, et cetera, the concept of bringing improvement to where someone already lives, whether it's in Salesforce, whether it's in Tableau, maybe it's some reporting system or some application for healthcare, whatever the situation would be, if you're not then selling change, because change, oh, no. No, now you're selling improvement. Who doesn't want to improve what they're doing? So now you're getting really smart on how to sell the business on this. And let's look at another example of end-to-end, what this might look like in predictions, and then how we're going to use this. So this is one that I've built. The data set itself is from Kaggle, so folks that are familiar with Kaggle. I've downloaded, it was the auctions data from there, and I've customized it for my Mazda. I did have to tweak it a little bit, but it is essentially the same. These are, at least in the United States, were the 3 auctioneers where I could have gotten my bad car. And I have here now, I've got my concept of total predictions, so you can get a feeling for how many are predicted to happen. I've got my little lemon icon, so for folks that can't see that, again, I come fully themed for my stories. And then we can go ahead and look, and here's Mazda. And I only care about Mazda right now because that's where I got burned. Sure enough, if I start to dig down and look, here's my RX-7. It's yellow, but it also has almost 42% of lemons. So it's way high. If I look at this particular visualization, no one else is even close to my little Mazda. So that's, yeah, I should have done a little more Google searching before buying that car. So taking it a little further, if you look at, and now we're looking, remember I talked about the concepts of prediction explanations and different creative ways that you might display predictions and explanations. Interestingly enough, wheels are one of the key predictors for a lemon card. And anyone want to guess what the wheel type is? Missing. It's missing. And again, when you think about humans, and yeah, does this model make sense? Guess what? When I went back to the dealer that sold me the car and said, oh, I want to give you this car back, how much can I get? I paid, I don't know, probably almost 20,000 USD. And they say, oh, well, we'll give you 1,000. He says, I'll just sell the tires. And so when other people have lemon cars and they can't do anything, they sell the parts. So that was one of the key findings in here about this. The other thing was date, and date makes a thing too. So as the manufacturers were building cars, it was a date range where they found out these rotary engines weren't too good, that they were problematic. And I just happened to be right in that window of time. If I look at my little lemons here, each one of these, and now I'll just make it a little bigger so you can see them. Now you can see the different reasons why. And you can do this much more creatively. I leave the pluses and minuses for my data scientists that have to see exactly what's on the screen in DataRobot. But for humans, I've also done this where I've done a calculated field in Tableau, 3 pluses, IIF, or a case statement just saying most influences, least influences, to make it very user-friendly as well to the business. And that's actually much more friendly that I would prefer to do and show. And from a trends perspective, now you can see, that's just another way of just looking at it. And we can do the same type of what-if analysis if I wanted to. You just saw what-if analysis, so I'm going to dig deeper. We want to open up the models this time instead. So looking at this point, yay, we've sold the business. You have an executive sponsor. We have the data. Let's go ahead now and build some models. And we're going to look at, again, remember to trust them, we need to open up that black box. Because we want to understand what's not making mistakes, because you don't want to be the next news headline. And the bigger the company does not mean the better. It's not, if you think about Amazon had an issue last year with the bias in human resource algorithms by full-on data scientists for gender issues and all the different types of things. And we've certainly seen Microsoft had the Tay thing that went wild and crazy. So bigger is not always better. Data scientists can fail. You do need to look behind the model. So let's open up the black box a bit more. This is going to look a little complicated. It is a book that supplements this, and let me show you where you can get this book. I have a website, jennaunderwood.com, and we don't even make you sign up for this. This is how important I think it is for this. DataRobot has a whole blog series on data literacy with this. If you go into this very top one right now, there is a free ebook in here, Understanding Models. It's going to explain each one of these charts that I'm showing in much, much more detail and tell you when to use them. So this is a good one for you to look at. But looking at the black box of models and when to use each one, let's go back to that for a second. There's a few different keys in here. So it's a cheat sheet for, and there's a couple different ones that I've put in here. There's DrY.ai is another similar one. So there's one, I think it's called Raylex maybe, or Daylex. So there's different types of depending on what you're using. But essentially, they're all doing the same thing. Do you want to understand the whole model and what influences that whole model? So that was like that feature impact that I showed you, or what matters most? Or the individual predictions themselves, where I was showing you the individual discrete predictions for the what and why for each one. Are you looking at, again, if it's individual predictions, you might be looking at business rules. You might be looking at the values of individual ones. We also have word clouds as well for non-technical audiences to understand. Do you want to find important patterns or rows? So you might look at things. I didn't show this, but there's just the ability to just look at anomalies. There's other types of businesses where when you look at, I need to know the exact formula. So you may need to take your prediction and look at the formula behind it to say, what does it matter? Banks need this. So in model validation, we work with a lot of the banks. They have to have that. And then another really fun thing, and Scott from Farmers Insurance that spoke at Tableau conference in New Orleans last year with me, he had talked about comparing models and adding free text fields to your models because it would help in predictive lift. So comparing models and performance, trying different experiments, and data mining and machine learning, predictive analytics, whatever you want to call this, AI, it depends on what era you're from is what you call it. Essentially, it's very iterative and experimentative. So you will want to experiment, you will want to compare. So in doing that, there's different types of charts that you can compare again in looking at this. So as you're starting and you look at what's behind the model itself, you want to look at the data that trained the model. And that's important because we'll look at things like those summary statistics, those distributions, outliers, correlations. In some model types, outliers can grossly affect the outcome and the performance of that model. So you will want to treat them in the data itself. DataRobot handles that. In some cases, some of the other solutions you may be using may not. So just be aware that you will want to be aware if your solution can handle that or not. You'll want to look for data quality issues. Your data doesn't have to be perfect. But if you do have significant data quality issues, keep in mind the machine is going to just believe what you put in it that doesn't understand this. You'll want to be careful that you don't accidentally provide the answers. And again, remember I showed you that big process flow? In order for me to know something is a lemon or not, if I include the arbitration data, I've already given it the answer. Yeah, I wouldn't be in arbitration and going back to the dealer and asking for my money back if it wasn't. So if you go through the process flow or you just pointed at all the data, I guarantee you it will be a problem. That's why the human in understanding the business process is so crucial, so that you really are training it correctly with the right environmental data for your problem. We've talked about this, what matters most, in quickly finding some of those outcomes. Finding different business rules from your data, so that is something that can be really important. And one thing that as data visualization connoisseurs, we've probably poo-pooed on word clouds and been like, no. But I'll tell you, healthcare, very young audiences that would never build a dashboard in their life, but they want to use data and you want to help everybody democratize AI. Something as simple as a word cloud can be really powerful. So in the reds, we know WinStars were not so good, maybe Maximas weren't such good cars, but the blues are better. And a 14-year-old child, you just tell them, red is bad and blue is good. They get that instantly, and you can do that as well. And you can also show that in Tableau. So let me show you really quickly how I did that in Tableau. I'm sorry? What was the question?
What does the size mean?
Oh, that should be the count of them, how many? So let's look and see. So this is the example in Tableau. And essentially, I've just took the absolute values here, and we're just showing it a little differently. And again, how to transfer them for folks that want to know. It's just a simple integration copy-paste there of that value. For this next one, and this is the actual values for the vehicles themselves for looking at that data underneath the model, this is what the data scientists would call, and I've mentioned this before, partial dependence plot. But in case really this is just the values that make a difference. So this is the odometer reading. My car had 40,000 miles, not very many. You should have like 100. But here, so my car had this. It should have, to be a bad car, much higher. So that's what you would expect in most models. So if I just took the data, or I looked and isolated that for Mazda, it wouldn't have performed very well. The next type of thing that you might look at, there's two different chart types here. It's another way to look at the partial dependence plot I showed you, but for all of them. So now we'll just look at all of them together, and we can just highlight or look at specific ones, and you can get a feeling for the range or the distributions that you might be finding in that value. Why, what if? We've talked about this already, just being able to quickly show that for humans, and I've shown you in the Tableau example how to do that. There's some other ways, without getting too scientific about SHAP and LIME and XEMP and all these different methodologies for doing types of prediction explanations. You can look at it globally through the whole model and visualize that effect. Again, similar to feature impact, but now we're just looking at it a little differently. Or we've done this historically, and I've seen some beautiful examples, even in Salesforce's products, on just being able to show the differences in the impact with a waterfall. Evaluating the models themselves. So now we got to, what do errors mean? This has probably been one of the most powerful things that even when I was doing manual scripted models back in the day, really looking at feeding it in for the first time. Let's just take it. You'll never have completely perfect data. Let's just take what we've got, and we'll continue getting better over time. But to make the model perform better, you want to see where it makes mistakes. And I've been using Tableau to do this since like 2010. So it's one of the wonderful tools for looking and exploring where errors are happening, and exploring and slicing and dicing and visualizing what does the model get right and what does it get wrong. And one of the tricks that I've had through the years is I'll find a model, we'll go ahead and we'll just put it in kind of a pilot, kind of a sandbox mode, and then we're going to look at the actual results, and then we'll combine those data and see what's truly gotten it right and truly wrong, and then looking at the accuracy of them. So you can do this in data science gobbledygook. We'll call it rock curves. And there's other ways that we can do, box plots and looking at the accuracy again. But we're going to make this a bit more human in just a moment. But you'll hear these concepts. And this is when you talk about data literacy, understanding how to review the model. Hopefully your data scientists will do that for you. But other ways that you can do this in Tableau that might be a bit easier for you to understand is, where is it making mistakes? So things like residuals. And we've had residuals. If anyone remember Bora Beren? Phenomenal resource. He has phenomenal blogs they still reside on Tableau.com somewhere, but they're quite good. But we have some wonderful videos in this one. Again, where are the mistakes happening, and looking at the distribution of errors. You can look at it for time series problems. Maybe you're just looking at, again, we're looking at the difference or where the sales are and the patterns of where errors are happening. And that's pretty easy to do. Looking at what my data scientists do, it's been a journey to get them to use Tableau because they're so used to scripting in R and Python. But as I'm watching them, and this, bringing these two worlds together, it's been absolutely fascinating. So there are a few things that I'm seeing them do as well. A confusion matrix, again, a kind of a confusing term. What this really means is, what did it get right that was correct, and what did it get wrong? And you can take these, and this is how you're going to measure, and depending on what's important on getting right and wrong, would you put the value to. So if you think about, it may not be expensive to get right and wrong if you mailed a brochure to someone that's not likely to buy, but it would be very expensive if the part, you predicted a part that wouldn't fail that did fail on an airplane when I'm flying back home to Florida to my puppies. It's those types of things of looking at, what does an error mean? It's super important in assigning these true positives, false positives, what we would call right and wrong. The other key that we're doing here is, as you start to get, okay, let's run the model, let's just see what we get. Let's just dig in here, we're going to open it up and see how it does. One of the things, again, taking dimensions and looking at, this is an actual screenshot of a Tableau one of my data scientists from New York used working with the bank on interest rate bins. So now he's looking at, well, these different range of bins where it doesn't have too many errors. And just looking at where, again, you're getting issues. And you can kind of see and refine, and again, very experimental with what values you might feed in. And again, trying to improve, well, how can we maybe improve the model? The next thing that we're seeing in the industry, and I'm seeing creative ways, and we've been doing this for as long as I've been designing product, has this concept of cost-benefit sensitivity and looking at where the model makes mistakes and whatnot, but also assigning the values. So we'll put payoffs to this, and we'll rank them, and it may not be the best performing model that has the best payoff. So it's one of those types of things, again, of looking at, and this is another Tableau example this is a different, I think this data scientist is in Chicago, that put together the true positive benefits, the false positive costs. So he's got some variables inside of Tableau. So we're just dropping some variables, or parameters, I think is what they're called. And then we can look at the threshold and just look at where would it optimize at what point. So how you get that into Tableau, in DataRobot, I can right-click and I can look at, we have an extension for downloading different types of data summaries, but that's how we would do it. There's many ways that you could do that with other tools. Probably my favorite example, and I will absolutely be ecstatic if I get time to build this one day, or somebody else builds this, maybe Richard will build this for me. This is probably one of the best examples I've seen of explainable BI in the industry. And let me just go to the real one. Let me show you the real one. So for this one, the group is, and you can play with this as well, the Berkeley Artificial Intelligence Research. So it's looking at the impacts of machine learning and making this, again, explainable to the business and having the business understand this, but taking this to a whole nother level. So when they're looking at this, one thing that we have is a concept of, here's the decision of the loan thresholds, and as I take this little bar, I can see, and there's probably a way to do this in Tableau with parameters, I can see how it changes my profits. And we talked about true positives and false positives. Denied a loan would default. Yep, that was a good decision. Denied a loan, but actually they'd paid back. That means we've lost money. We could have given them the loan. Granted loan pays back. So instead of saying true positive, false positive, like business doesn't understand that. They do get this. They do understand that. We also have it color-coded. So we can look at the differences and how it affects as well the credit score changes. So we're experimenting, we're what-ifing credit score change and looking at profit visually. So it's all interactive and showing them visually. This is something Tableau should be wonderful at doing, of explaining what this means to the business in these different decisions. The next one we have, and this one's a source of the Bank of England. However, I'm also seeing this called prediction intervals. By the data scientists that I'm working with. And basically it's the ranges, and you're looking at kind of the probabilities of, it's not just a number. So when you say you have the likelihood of 50% readmission, 60%, 70%, it's a likelihood. It's not a fact. It's not historical, like historical sales. And you have to remind executives that it's going to range, and what's a high range and what's a low range and what's the context historically to really give them a good idea. And another thing that's good, and I'm seeing our own data scientists do this, is giving a range, like coloring, just making a really color-coded, this is what we're predicting, so that they really understand what they're predicting versus what is a known. These are other examples, not by me, by the Tableau community, that I think do a wonderful job of the same concept of visualizing probabilities. So this one here is by Ramon Martinez. He has his trends over time, as well as some of the distributions here. And we also have from 538, is this the right one? I don't think this is the right source for this. Well, maybe it is.
Yeah, they explain, because they said hurricanes, people understand, elections, they don't.
oh, is that what this is? Yeah, I'm like, did I put the wrong label here? I want to make sure I give everybody credit appropriately. But this is wonderful, and this is another one. I live right here. My husband manages the power grid in Florida for the whole power grid. So for us, it was a massive ordeal. But this is the first time in history it actually did hit up the whole thing. But we were looking, and it was supposed to be here, and I'll never forget it. And then all of a sudden, within a day, it had shifted over into our side, and then it was a direct hit for Tampa, which, you know, we have our own house, and it's a special experience to pack up your whole house and have little puppies in the hallway, and you're like, oh, we don't even have any wood or anything. But this, what I do like is it gives you, again, an idea of how to use color ranges to describe probabilities and shift over time. My other one, and I'll leave you, I think, on this one. I think this is one of my last ones, and I'll take some questions. Visualizing probabilities. This one is absolutely beautiful. I don't know if I'm going to say this name correctly. Olivier, Catherine? It's wonderful. And why I like this is you think about, I started with that business process in the lemon of saying, like, look at all the steps we can improve, right? Once you do have the business, you have transformed your business process, there's different steps in a process. So in this case, I think they're using the typical Tableau, office supplies, furniture, technology. But if you imagine just saying this is the probability of the bad cars, maybe, you can look at the different steps in the process to really isolate, was it a lazy inspector? Maybe there's just a group that had a bad buyer. Maybe it's just fraudulent activity at one place. It really helps you identify the source and where in the business process with a sand key diagram. And I haven't seen this really used yet. Again, we're on the bleeding edge of bridging these two worlds together. So as I get inspired, I'm trying to inspire you to take us a whole nother level. One other thing to note about predictive analytics, it's not a one-time deal. You build a model and you're done. The data always changes, and I always think about the market crash of 2008. It really changed whether you'd get a loan or whether you'd get a job, et cetera, in September that year versus November of that year. The data changes over time. Some other things to be thinking about that you can do, again, looking at the ranges and color coding. I've got a little indicator here. We have a problem with the data that day. But there's also something that you can do. You can look at specifically what values changed over time that might be affecting that got the model wrong. So when you start analyzing where, looking at the specific features or dimensions values in Tableau of what is wrong. Because what you're going to look at is say, wow, my performance and what the executive says. And I've had these conversations with one of our case study accounts, Well in Capital, called and said, one of the biggest things we want to understand is I finally taught my executive what rock curve means, and now they want to know why it went down. So it was one of the inspirations for saying, oh, well, let's make that easier for you to do and just not make it a painful process to just find what went wrong. And last but not least, be sure to, when you do monetize this and you start to track your performance over time and what you're getting right and wrong so that you can go in and get that big raise next year because you've upskilled your talents to become an AI interpreter and an AI storyteller, is keeping track of your portfolio over time. And this is definitely not anything new for this particular group, but just tracking the impact of the projects that you're making yourselves. And then my last 5 tips for success. So what we showed today was designing actionable models, starting with the end in mind, selling the vision, and then working with the business. Selecting the right metric to predict, that's important. We didn't go too far into that today, but one of the keys too is just looking at how your model is going to be used so you're communicating that metric properly to the business and always communicating the historical probabilities and the ranges that they're used to seeing. So some next steps. I have the link in here for folks that get this deck. We have Tableau Starter Kit. We also have the Understanding Models. Those are other resources that are available for you. One of my favorite resources on this for my data scientists, if you're not following him, I think he's probably my favorite, is Christoph Molnar, has a GitHub. It's a free book. So if you want to learn about really analyzing this and becoming an AI interpreter, this book is fantastic. It's just a free GitHub PDF. There's also Dr. Y, and some other ones with examples in R and Python. So let me just go to this really quickly, and I'll say I've showed you our way, but certainly we're not the only folks doing this concept today. This is another one of Dr. Y has his own little cheat sheet, but they're all doing the same types of things at the end of the day. So that's just another example of another one. And again, looking at instance versus batch explanations. There's many really cool resources for you to learn more about this. All right. And now I'll stay for some questions. Thank you. Any questions?